two different methods that you can choose from in order to work with complex fractions. Complex fractions are fractions that have fractions inside of them, so a fraction within a fraction. So here, when you look at this entire expression, we have one fraction over another fraction. So you have this big outer fraction, the complex fraction, and then you have the expressions in the numerator and in the denominator. Okay, so one of the options for approaching these is to, and again I'll refer to it as method 1, which is just going to be combined fractions. So this is going to be, you convert your numerator into a single fraction, convert your denominator into a single fraction. Okay, so our first step would be to write the numerator as a single fraction, okay, and then follow that with the same thing for the denominator. Write the denominator as a single fraction. Okay, so if we work through this, okay, in order to combine this numerator as a single fraction, we're going to rewrite this as a single fraction using just the LCD of the two fractions involved. So we need a factor of x minus 5. We need a factor of x plus 3. So here's our LCD for these two fractions. When we combine them into one single fraction, we take the numerator of our first fraction times the LCD factor that was missing from its denominator. What factor was missing from this denominator? It has the x minus 5, it's missing the x plus 3. And then we take plus 2, the next fraction's numerator, times the missing LCD factor from its denominator. It has the x plus 3, it's missing x minus 5. So if we continue to work with these, we need to FOIL this out. So when we FOIL, we get x squared plus 3x plus 1x gives us plus 4x. And then our last terms plus 3. Okay, and then we're going to distribute this 2. We get a plus 2x and a minus 10. And so when we combine our entire numerator of that red fraction, we get x squared plus 6x minus 7. And so one last thing is to look to see, are there any factors that would allow us to rewrite this as binomial factors? And those two factors would have a first term of x. The second terms are going to be the two factors of negative 7, whose sum is the middle term, positive 6. So plus 7 and minus 1. So here is our numerator. So we can rewrite this fraction here as x plus 7 times x minus 1 all over x minus 5 times x plus 3. Okay, so we've completed step 1. Now we move to step 2 and we do the exact same thing with just the fractions in the denominator. So when we do that, we can combine these into one single fraction. So you need the LCD factor of x plus 3 and x minus 5. We take the numerator of our first fraction, multiply it by the LCD factor missing from its denominator. It's missing x minus 5, plus the next fraction's numerator x times the LCD factor that's missing from the second fraction's denominator. It has the x minus 5, it's missing x plus 3. Okay, so now it's just a matter of, again, distributing through. We get x squared minus 5x, distribute through. We get a plus x squared plus 3x. And so when we simplify this, we get a total of 2x squared minus 2x, which when we write it, we can factor out a 2 and an x, and that leaves x minus 1. Okay, so here is our green fraction written as a single fraction. We have 2x times x minus 1 in the numerator, and then our denominator are the two factors, x plus 3 and x minus 5. Okay, so those are the first two steps. Okay, by rewriting or combining these into single fractions, this now becomes a fraction divided by a fraction. And what you can now do, instead of dividing is equivalent to multiplying by the what? Reciprocal. So we can now just invert and multiply. So now it becomes like a problem that we did in 4.2, dividing fractions. So what we're going to do here is we're now going to take everything that was in the denominator here, we're going to move it up, and we're going to invert and multiply. So the denominator factors of x plus 3 and x minus 5 get moved to the numerator, and the numerator factors in green get moved to the denominator. And your final step then becomes to simplify. So simplify includes canceling any common factors, so the x plus 3's cancel, the x minus 5's cancel, okay, the x minus 1's cancel. So we get all our canceled factors, and then we write our simplified answer. Along the top we have x plus 7. In the denominator all we have is a 2x. Okay, and there were lots of factors that got canceled. Okay, remember, because we're dealing with a division problem, if you recall in dividing, we need to consider all factors in the denominators as well as the numerator and denominator of the second fraction, the one that we inverted and multiplied. So we have to consider every single one of these factors as potential restrictions into the domain. So we see x can't be 5, negative 3, 0, 1, negative 3, 5. These are just repeated factors. Okay, so when we test these, I'm just going to start with the smallest number, the one furthest to the left on a number line. So negative 3 is the restriction that x can't be negative 3 shown in our simplified form? No, so we have to list that. Okay, so we've accounted for those two. Next, go to 0. Is the restriction that x can't be 0 shown in our simplified form? Yeah, so we don't even need to include that one. What about 1? Is that restriction shown? Nope, so we include it. And then finally, what about 5? That's not shown, so we have to include it. Again, it was repeated up here. And so we get our final solution to be x plus 7 over 2x, okay? X not equal to negative 3, 1, and 5.